Hi, in this video, I'm going to talk about antimatter. So antimatter, you might have heard often in the science fiction movies and novels. It's a real thing. It's not a fiction. It's a real thing. For example, when you do collide, there's a high energy lab, right? There's a big accelerator. The biggest one right now is in border between France and Switzerland in Europe that has a huge accelerator. Over there, it's because it's so large that it's enormous amount of energy that goes in, and you create all kinds of new particles, and you can see so different kinds of fundamental particles. And over there, whenever you are making the new particles and then during this collision, it's always 50% when you collide it and then you produce a new particles. When you have new particles that's been generated, it's always 50% that you get matter and antimatter. You, anti-you. So what's matter and antimatter? What is the difference? It's exact the same thing, except antimatter and matter and antimatter has a different electrical charge. So matter has let's see. Oh yeah, gotta share the screen first. Okay, so the matter, antimatter. So we are talking about antimatter now. When you hear matter, that's a positively charged nuclei, right? Matter has a positively charged nuclei. And negatively charged, what is it? Electrons. What's antimatter? Antimatter has negatively charged nuclei and positively charged particle. And this, let's see, yellow is hard to see. This is called positron. So antimatter of electron is called positron. It's hard to distinguish the two. Matter from antimatter or antimatter from matter, because they both of them have the same mass, so it's the same, gravitational force is the same. It's interesting, it's the same, right? So so it's hard to distinguish the two. What happens is that when you have an antimatter and matter collide, when it touches each other, they annihilate. So um, when you have a matter and antimatter meet, then annihilation. It's gonna burst some energy and disappear. You heard of E equals mc squared, right? So in this case, matter and antimatter, they meet. Matter and antimatter meet, and then it becomes equals 2 mc squared, 2m, m and m. Then c squared, and that amount of energy, it just changes into energy and disappear. So whenever you have a matter and antimatter, whenever antimatter meets the matter, it disappears. So that's why our universe or our system, everything is made of matter, right? So if we in a collider, it creates both matter and antimatter. But those the antimatter matter, that particle that's generated, soon it's going to meet the matter that's everywhere. You have walls and air. We shouldn't have air; it's an action vacuum system. But you have all the matters. So whenever this antimatter that's generated, um, as soon as it meets the matter, boom, it converts into energy and it annihilates. So that's why we don't see antimatter, because we already have a bunch of matter. Um, we do have from the solar energy and things, and we may have those cosmic ray that consist of antimatter that's hitting us. But again, our atmosphere is made of matter. So before it hits us, it meets, it disappears, it annihilates by meeting our atmosphere. So you can generate antimatter or observe antimatter by using a particle accelerator, or even the radioactive decay. When things radioactively decays, it creates antimatter. I mentioned that electrons, antimatter of electron is a positron. So here is the matter. So we have an electron. An antimatter of an electron is called a positron. Sorry, positron. Exact same mass. It's just that electron is negatively charged and a positron is positively charged. But it's not that antimatter of electron is not the proton. Proton, remember, is made of 3 quarks. What was it? Up, up, down, right? And those quarks, up, down, strange, charm, top, and bottom, they all have antimatter, each of them. Anti-U, anti-D, anti-up, anti-down. So the proton, antiproton, are all made of antiquarks. So we have a proton and there is a antiproton, right? The It's not electrons. Antimatter is not a proton, although they're oppositely charged. Proton weighs more than electrons because proton is made of 3 quarks. Electron itself is a lepton. So all those lepton particles, so as including neutrino, they have antimatter, anti-neutrino, neutrino, anti-electrons, positron. And so was all the quarks. Each quarks have anti-quarks. So proton and antiproton is made of anti-quarks. And that means that we could have a hydrogen atom and anti-hydrogen are made of antiproton and positron. So there could be U and there could be anti-U. Just make sure when you find anti-U, do not touch it, right? Then you're going to burst into energy and we disappear. So that's the antimatter. It's a true thing. Again, we can observe it. You might have heard also dark matter. Dark matter is also true. Because of all this evolution, how the galaxies is formed and how universe is expanding, there are significantly missing matters. And only 23% of the matter in the universe is composed of almost 23% of matter in the universe is composed of dark matter. We don't see. It's missing. All those masses are missing. And we can't find what it is. It could be black hole. It could be... So I mentioned that neutrino doesn't have any mass. It's lepton particle that we say it has no mass, but I also mentioned that recently we proved that it has a mass. Tiny mass. But because they don't interact with any, they don't interact. That's why it's hard for us to observe, right? There's no electric charge. So it just passed through. It could be just passing through us all the time. So there could be abundant. We could be all filling with neutrino right now. And we don't feel it because it doesn't interact. And then all those abundant neutrino, if they even have a tiny one, it could be making a part of the dark matter. We don't know. So there are some candidates of dark matters. But yes, and then there is also a dark energy that we don't know what kind of energy, but that's the missing energy. So those are the things that it's true. It's not just a science fiction. And we haven't still found what they are. Okay, so in this video, and this is the last part of the, let me just show you something to be fun. Why don't I share the screen? Here. So antimatter and matter. Matter composed of atoms with positive nuclei and negative electrons. Antimatter has the negative nuclei and positive electrons. It's the opposite, they charged. And they cannot share the same space. And when they meet, they annihilate and burst energy. So this is the huge accelerator I was talking about. That's called LHC accelerator at CERN. CERN is at border between France and Switzerland. Most of the scientists live in France side because Switzerland is expensive. So you see the housings and all that stuff is on the France side, but it's in between the border of France and Switzerland. This collider is so large. There's a 27 kilometers in circumference. And it makes protons, we laps 11,000 laps every second for 20 minutes. So imagine how much energy is going to be made. It can shoot protons for 11,000 laps for 27 kilometers every second. And then we shoot it and then it creates so much energy, and we make all different kinds of particles. So it's a crazy thing. And the energy, because we use electromagnets, so we want to keep the temperature down to almost zero, right? To reduce any of the dissipation, and to make it superconducting, so we don't lose any, we don't have any dissipation energy. Again, the positron is the antimatter of electron, and the antiproton is the antimatter of proton. Don't get confused with the two. Okay. Dark matter is unseen matter. We don't know what it is, but it seems like about 23% of matter in the universe are missing. Dark energy is not some kind of an energy that's actually making 73% of the universe that we don't know where is this coming from. So that's the end of this chapter, chapter 11. And I hope you enjoy the first chapter we're doing in a class. And I'll see you in the discussion. And next chapter we're going to talk about is chapter 2. See you in the class.